Hi friends, today's math lesson has to do with calculating measuring area again. And before we go ahead and look at today's lesson, I'd like you to look at this whiteboard because I'm going to show you just a quick review of how to calculate area and how to write a multiplication using area because we have been doing that, but just a quick review. So don't forget, rows go across, columns go down. When we write a multiplication sentence for a figure like this, we first look at the rows, right? How many rows in this figure? 1, 2. That's why we write 2 times how many in each row? 1, 2, 3. 3. I'm going to say the units that I want to use for this figure is our centimeters. So I'm going to say the answer is not just 6, it's going to be 6 squared centimeters. That's how you would write it. Okay, so a quick review of how you calculate, how you write a multiplication sentence for a figure. Now this is going to help us for today's lesson. Let's take a look. So the anchor task is asking us here, we have a friend, there's a figure over here. You can see that it looks like almost like an L. And so this friend is asking, think of different ways to figure the area of, but think of different ways to find the area of this figure. So what are some ways you can figure out the surface, the inside part of this figure, right? So you can count squares, but we're going to ask you to stretch your thinking a little bit further and think of other ways you can find the area. Okay, so if you have not calculated the anchor task, pause the video right now and try it. And then we're going to ask you way 1 or way 2, 2 ways. And then if you have any other ways, just if you can just write it down on a scrap piece of paper, okay? So hopefully you've had some time to calculate, and this is how we go ahead, some ways to calculate the area of that one figure. One way is our friends decided to break it into 2 rectangles, a small one up top, another larger one underneath, and they labeled it A and B. So in order to find the total area, don't forget, we're going to find the area of this rectangle A and then B, and then guess what we're going to do? Add them together. Okay, so units are centimeters. So for area A, look at the rows. How many rows? 1, 2, right? That's that 2 right here. And how many in each row? 1, 2, 3, 4. There's that 4. Okay, so 2 times 4 is 8, except it's 8 square centimeters. Now for B, same thing. How many rows? 1, 2, 3. There's that 3 right here. How many in each row? Ready? 1, 2, 3, 4, 5, 6, 7, 8. There's that 8. 3 times 8 is 24 squared centimeters, right? So now we're going to take this 8 and this 24 and add them together to get 32 squared centimeters. That is the total area for A and B. Okay, and don't forget the symbol for squared centimeters is that centimeter with the little 2 at the top. Okay, I'm just going to erase this so it doesn't travel down with us. Let's take a look at another way. This friend decided I'm going to now not put the little skinny rectangle up top. I'm going to have a bigger rectangle over here. It's labeled C and another one next to it. Again, how many rows for C? 1, 2, 3, 4, 5. Area of C, there is that 5. How many in each row? 1, 2, 3, 4. There is that 4. 5 times 4 is 20. Now for D, same thing. 3 rows. 1, 2, 3, 4. 4 in each row. 3 times 4 is 12. So what are we going to add down over here to find the area? We're going to add the 20 and the 12. So it's going to be 20 plus 12, which will give us 32 squared centimeters. Okay, so that is the area. Notice that we did not change. It did not change, right? If we look up here, it's going to be the same, 32. So we can see that just because we're breaking it into different ways, right, doesn't change the area of the shape. So it's really important to note that. And so we're going to go down over here and take a look. So down over here, now again, this friend decided, I'm not going to break it into 2 different rectangles. I'm going to break it into 3, E, F, and G. She found the area of each one, 8 squared centimeters for E, 12 squared centimeters for F, and 12 for G. So we need to add them. 8 plus 12, that's 20, plus another 12, that gives us 32 again, okay? And you can always get a scrap piece of paper and use standard column method. We don't want to lose that. That's a really great practice, so to do that. Now, something else that she's noting over here is that another way to kind of think about this is if we can take this rectangle and almost bring it down over here, like this. That's what she's showing in her picture right over here. And so if we bring this rectangle down over here and we count the number of rows, okay, now this one has 3 rows, right? So keep that 3 in your mind. And then this would be 4, 5, 6, 7, 8. So here we would write 8 rows, right? And how many in each one? 1, 2, 3, 4. That is where she gets that 4 from. So another way is to kind of play around with the figures and kind of stack them. If that does not work for you, no worries. Just use this method right over here, okay? But that's just one way to look at it. We just wanted to show you that. So I'm going to erase this again so it doesn't travel down. And down below, there's another method, which is asking you to think kind of, this is a challenge. So think outside of your box, outside of the box. So down over here, this friend is saying, you know what? I'm going to look at this purple figure as one big rectangle. And in case you can't see that, this friend decided I'm going to kind of look at it like this. You can see the outline of the rectangle that I'm drawing, right? This is H that he's thinking about. And then he said, and then I'm going to take this part out. So how would we do that? Can you continue his method is a question. Can you continue his method, right? And our friend is saying, what if this is broken into these different parts? So there's another way of doing it too. But if we did it this way, how would we do that? So for this way of thinking, H, we would count the rows. 1, 2, 3, 4, 5, right? I'm going to make sure I write that down. 5 times. Now over here, how many in each row? 1, 2, 3, 4, 5, 6, 7, 8. 5 times 8 squared centimeters, right? So it's going to be 40, right? 40 squared centimeters. I'm not going to forget that little 2 at the top. Whoops. So the answer for this entire rectangle is 40 squared centimeters, but that's not what I want because this part over here is not part of the figure. And that's what he's saying over here. So in order to figure out this purple part, what I can do is now the next thing. So I know that this is all 40. I need to figure out the area of this small one. So for this one right over here, I can say it's 2 rows, right? 2 times. And for this one, we have 1, 2, 3, 4. 4 going across. So what is 2 times 4? Did you say 8? I hope so. And it's so 8 squared centimeters. So now what I need to do is, because this is not part of it, it's taking it away. And so when you think about the action of taking away, what operation do you think of? Subtraction. So we're going to do 40 minus 8, right? And that will give us 32, and I don't want to forget my units, squared centimeters. So that is another way to kind of look at how to figure out that area. Okay, so down over here, there are some other questions for you. And it says here, the first figure is for you to look at. So please don't look at this and get confused. This is for you to look at. What we have done, we were trying to figure out how we can do this because we're not there to sit next to you to see the different ways. So we broke it down for you. So for this figure, there's so many other ways to break this one down, but we just showed you one way, right? This is just one way to break it down. This is the long rectangle at the top. Then we broke it down into a square at the bottom. So now you're going to figure out the area of A and B and then do what? Add it together, okay, to figure that out. So please make sure you go ahead and do that. And then down below over here, you have some curriculum extension if you'd like to do more practice. Okay, have fun and we'll see you later. Bye.